Hello everyone, in this video we will be talking about the assembly of LARCSet, a 5 watt 7 MHz super heterodyne transceiver kit capable of CW and SSB. For assembly of this LARCSet, you may need tools like nose pliers, wire cutter, blade, soldering iron, solder wire, paste and wick. Before we begin, let's quickly take a look at what you will receive inside the kit and the components you will be working with. So this is the front panel. We have a PCB here, that's the main PCB of the radio. We have the toroids and the insulated copper wire. We have a checklist to make sure that you have received all the components. A pack of super glue, volume control port, tuner knob, BNC connector, tuner pot, and other components like heat sink, the MOSFET, the relays, and the audiophone connectors. For operations, you have to supply an external mic, a speaker, and 12 volt DC power supply. The first step is to install the DC components, and here we have to snap off the two side rails of this PCB. You can use normal nose pliers for this. This is step 1.1. Next, we need to solder the DC socket onto the PCB. To do this, carefully place the DC socket into the PCB, flip the board upside down and press it gently so all the 3 pins of the DC socket are fully inserted. Then solder them properly. Make sure to apply sufficient solder to these points since they will carry high current. Moving forward to step 1.2, we have this relay and we need to solder this relay K1 onto the PCB. You have to carefully place the relay and ensure all its pins are properly aligned and inserted. It's common for pins to bend instead of going through the holes, so you have to make sure. Once soldered, this cannot be corrected easily, so double check that all pins are visible on the other side before soldering. So far so good. We have successfully completed step 1.2. Moving to step 2, we need to install the front panel. The front panel is supported by these audio jacks. Step 2.1 is to installing these audio jacks. First we need to remove the mounting nuts, ring-shaped parts, from the audio jackets before inserting them into the PCB. Keep them safely aside as they will be required later. Insert the 3 audio jacks. Check each pin carefully to ensure they are properly aligned and inserted. Sometimes the pins may bend instead of going into the holes, so inspect closely. After confirming proper placement, press the connectors down so they sit firmly on the PCB. Repeat this for all 3 audio jacks. Note that the mounting ring should be removed before installing the audio connectors. Once you have fixed this audio jacks in PCB, you have to solder all the 3 audio jacks carefully. This completes the step 2.1. Now moving to step 2.2, we have to install the front panel. Place the front panel onto the 3 audio jack connectors. While holding it in place, screw the mounting rings back onto the connectors to secure the front panel firmly. You can use nose pliers if required. Insert the volume control potentiometer into the front panel with its pin facing upward towards the PCB. Secure it using its nut, again tightening it by hand for now. Now insert the tuning potentiometer into the front panel and secure it using its mounting nut. For now, you may tighten it by hand just enough to hold it in place. This is step 2.3. Now moving to step 2.5, attach the tuning knob to the tuning potentiometer shaft. When turning fully clockwise, the pointer should align at 6 o'clock position. Starting from 8 o'clock. So as you can see, it's in 6 o'clock position. Similarly, also trim the shaft length of the volume control if needed to fit the knob properly. This knob will automatically align such a way that it will start from 8 o'clock and end at 6 o'clock position. This completes step 2.5. The next step is 2.6, where we need to solder the wires from this potentiometer to PCB. Use 3 different wires to connect the controls to the PCB tabs. Keep the following points in mind. Pre-tin the wires before soldering them to the control or PCB. Keep the wires short, but not excessively short. They only carry audio or DC signals. The middle tab of the PCB must connect to the middle terminal of the potentiometer. You need to double verify this carefully. If you have, you can use different colored wires for easy identification. If the side wires connections are swapped, the tuning direction of the volume or the tuning behavior will reverse. If this happens, simply interchange the connections. This completes the tuning knob wiring. Now moving to volume control port. This completes the wiring of volume control port. Next step is 2.6, where we need to connect 2 wires from J8 power switch to on-off switch. Connect 2 wires from the on-off switch at the back of the volume control to J8 jumper point on the PCB. Here polarity doesn't matter. As you can see, you can understand how the backside of the front panel wiring should look like and carefully observe where each wire is connected. That's it for this. We have completed the initial assembly in part 1. It's time to power things up for the first time and verify that the most critical section of the radio, the DC power stage and the audio amplifier. Make sure your DC supply is set to plus 12 volts with the center pin positive and the outer sleeve as ground. Double check polarity before connecting. This is very important. Reversing polarity can damage components instantly. Also keep a multimeter and an external speaker with audio jack connector. I have prepared a small helper assembly using a DC jack DC socket and two alligator clips. This makes it very easy to measure the current drawn by the circuit. Before plugging in power, ensure that the radio is switched off. In this design, the power switch is integrated into the volume potentiometer. Turn it fully counterclockwise until you hear a soft click noise. That confirms the unit is off. Using this cable assembly, whenever I want to measure current, I simply connect my multimeter in series using these alligator clips. And once I am done testing, I can remove this setup and directly connect the power jack to the board. This simply saves the time and avoids repeated soldering and desoldering. As we have already connected the plug in the DC power jack, now let us turn on the power socket. Now slowly turn the volume knob clockwise to switch on the radio. At this moment, observe the current reading on your multimeter. It should be somewhere between 40 milliampere to 70 milliampere. Now let's test the audio stage. Insert a pair of simple telephone earbuds into the leftmost audio jack. As you slowly turn the volume knob, you will hear the noise floor rising and falling smoothly. Now in my case, I don't have any earbuds handy, so I'll try using a speaker. I can hear the noise floor increasing and decreasing as I rotate the volume knob, but it's quite faint and so it may not be clearly audible in recording. So let me connect an external Bluetooth speaker using an aux cable. Now you should be able to clearly hear the noise variation. This confirms everything is working exactly as expected. At this point, you have completed step 3. Now we are moving on to the most important and interesting part of the radio, the VFO or the variable frequency oscillator. Find the larger yellow toroid core. This is the T56 toroid. We will wind around 31 turns of enameled copper wire on it. First of all, cut about 2 feet of wire. Pass the toroid through the wire so it sits roughly in the middle. Start winding carefully. Each pass through the toroid counts as 1 turn. Keep the wire tight, evenly spaced and non-overlapping. The turns should sit close together but never overlap. Traditionally, radios use variable frequency oscillators for tuning because they offer excellent phase noise performance. Complete 31 turns. Make sure that the turns are evenly spaced, non-overlapping and tight. Complete the 31 turns, trim the ends to about half an inch. Then scrape off the enamel coating until shiny metal is visible on all sides. This ensures proper electrical contact during soldering. Now solder the two ends into the L1 position on the PCB. Now I am using my UVK6 receiver in CW mode at 80-meter band with a small loop antenna. You should be able to tune from about 4.059 MHz down to at least 3.9 MHz. Also, I'll check these 2 points. At 4.059 MHz, while adjusting the knob, you should hear a strong high-pitched tone. Ignore weaker tones, they are just harmonics. Now checking at 3.9 MHz, you should again hear the tone if the tuning is correct. If not, adjust the coil space or turns. Also observe that turning clockwise lowers the frequency. This is important. Make sure your circuit behaves this way. If the frequency is too low, remove a turn and retry. If frequency is too high, spread the turns and add turns. These are the two options you have. At this stage, you may notice some drift. This is normal because the toroid is not yet fixed and the surrounding soldering affects stability. Once satisfied, apply a few drops of super glue, then press the toroid gently onto the PCB and hold it for about a minute. This stabilizes the VFO. At this point, we have completed step 4. Now moving to next step, the crystal filter and the BFO. This step is straightforward. You have to insert and solder the 5 crystals provided. Do this one at a time. Insert, solder, and then trim the leads. Once you're done, move to the next. This ensures clean and accurate placement. This completes the step 5. Now moving to next step, we need to solder the tri-filler transformers. This is a delicate and important step. Do it when you are fully alert. A trifilar transformer has 3 windings, meaning 6 wire ends. You need to identify the twisted wires. You will see 3 wires twisted together and wound on a toroid. You have to carefully separate each wire end on both sides. The wires are already tinned, which helps soldering, and before that you need to do a continuity test to identify matching pairs. Ensure that the continuity in pairs like A to A, B to B and C to C. No continuity between different pairs. This will help us to identify whether there is any short circuit between the coils. You have to repeat this for all 3 transformers provided in the kit. Once you are done, we need to insert wires into PCB carefully. You can use tweezers if needed. Make sure correct pairing is maintained. Ensure that only the tinned part is soldered. If enamel is still present, it may look soldered but it won't conduct. Repeat the same for the second transformer. Insert wires into the PCB carefully. Make sure correct pairing is maintained. Avoid the enamel soldering mistake. Make sure you solder only on the tinned part. Complete soldering of all trifilar transformers. Once you are done, your board should start looking much more complete. This marks the completion of step 6. Next is the RF band pass filters. We need to wind inductors L2 and L3. For that we need to cut 12 inches of wire for each toroid. Wind around 22 turns on smaller T36 toroid. You can follow the same procedure of winding that we discussed while winding L1 inductor. Maintain a tight winding. Keep turns tight and non-overlapping. They should nearly cover the toroid. Make sure you have wound around 22 turns. Now repeat the same method for the L3 inductor. Scrape off the enamel coating until shiny metal is visible on all sides. This ensures proper electrical contact during soldering. Repeat this for both the inductors. Now tin the leads of the inductor using a soldering iron and insert it in L2 and L3 positions into the PCB and carefully solder it. Trim the excess leads once you are done. Now your radio will look even closer to the completion. This marks the completion of step 7. Now next is installation of the BNC connector. We are almost done with the receiver section. Now install the BNC connector. This is straightforward. Insert it into the PCB, ensure pins are straight and solder firmly. Make sure that the RF pins are not bent away from the board. And that's it for part 2. In the next video, we'll complete the remaining steps and bring this radio fully to life. Thanks for watching. See you in part 3.
Today we are testing the receiver. This is step 9 in the manual. I have connected the transceiver to an external speaker using an aux cable and powered it with a 12 VSMPS. My smaller adapter was too noisy, and since this radio has high audio gain, it amplifies that noise. Even the SMPS adds a bit of noise, so I have placed a 4.7 mH inductor in the VCC line to clean things up. The radio is hooked up to a homebrew magloop antenna tuned to the 40 meter band. Let's tune in and see what we can hear. Due to limited time, I've used an AI voice assistant for the dubbing in this video. As we tune across the band, you can clearly hear active CW signals, including a few strong stations coming through. The current time is 7:55 IST. Unfortunately, there's no noticeable SSB activity right now. Either the band is quiet, or my antenna isn't picking up those signals at the moment. It's day 2, and we're starting off with a bright sunrise. Today, I've got the magloop antenna tuned to the 40 meter band, and I'm powering the radio using a 12 volts battery setup. The goal is simple: reduce noise and improve signal clarity. As I tune across the band, you can already notice a few strong stations coming in. That's likely the morning net, with the net controller leading the activity. Let's slowly tune around and see what else we can pick up. Now, tuning this setup clockwise can be a bit tricky. I'm using a linear potentiometer, but because of the nonlinear behavior of the varactor diode, the tuning response isn't exactly smooth. This makes fine tuning a bit tedious, especially if your hands aren't perfectly steady. And if they're shaky, well, you might miss the sweet spot entirely. Another thing you'll notice is a pile-up of stations toward the end of the tuning range. That's also a result of the same nonlinearity. One workaround some people suggest is adding an extra 20K potentiometer in series with the tuning port. That can help with coarse tuning and make the overall experience a bit more manageable. While tuning around, it's interesting to notice how the band conditions change even within a short span of time. Signals can fade in and out, and sometimes a weak station suddenly becomes readable for a few seconds before disappearing again. That's part of what makes working with the 40-meter band so exciting. There's always something unpredictable happening. I'll spend a bit more time scanning through the band, trying to catch any interesting QSOs or distant stations. If conditions improve, we might even get some really clean contacts coming through. Let me know in the comments if you've tried a similar setup, or if you have any tips to make tuning smoother or reduce noise further. Always curious to hear what others are experimenting with.
Good morning, algebra is 5 9 plus. What is something now? Total to Bhavnagar. Take them to the transmission here. Dharmendra Bhai, no. When we invited him for transit, they could not go. So, Dharmendra Bhai, in case if you are listening me, thank you very much for coming on the band. On this frequency. Let me hand over microphone to A41 Lima Delta Zero, Peter Lima Bravo.
This video, we are getting into one of the most exciting stages, the transmitter driver and the power amplifier. This is where your radio really starts to come alive, so take your time, follow along carefully, and I'll walk you through everything step by step as I replicate the process with you. Let's get started. Alright, first up, we're working on the transmitter driver section. We begin by preparing the inductors. Take two pieces of enameled wire, each about 7 inches long. These are going to become L6 and L7. Now grab your black FT37-43 toroid core. Carefully win 10 turns on each core. Try to keep the turns neat and evenly spaced. It really helps with consistent performance. Once both inductors are wound, scrape off the enamel from the ends of the wires. This step is important. If you don't remove the enamel properly, your soldered joints won't conduct. After scraping, tin the pigtails with a bit of solder so they're ready to go onto the board. Now go ahead and solder L6 and L7 into their respective positions on the PCB. Take a moment here to double check alignment and solder quality. Solid joints now save troubleshooting later. Next, we move on to the transistors. You will be installing Q19 and Q13, both 2 and 3905 transistors. These are through-hole components, so insert them carefully into the board. Pay attention to orientation. The flat side of each transistor should face away from the rear edge of the board. Once they're seated properly, solder them in place. Now, we install the PA bias trimmer. This is the small blue adjustable component. Place it in its designated spot and solder it carefully. After soldering, take a screwdriver and turn it fully clockwise. This sets the initial bias condition, which we'll fine-tune later. At this point, your transmitter driver section should be fully assembled. Take a quick look over everything. Inductor secure, transistors aligned correctly, and clean solder joints all around. Now we move on to the power amplifier stage. This is where your signal gets boosted for transmission. The main component here is the IRF 510 transistor, along with its heatsink. Start by attaching the IRF 510 to the heatsink using the supplied A3 screw. Make sure it's firmly tightened so heat can transfer effectively, but don't overdo it. If you tighten too much, you risk cracking the transistor case, which would damage the component. Once the IRF 510 is securely mounted, insert it into the PCB and solder it in place. Important: always install the heatsink before soldering the transistor. Trying to add it afterward can stress the leads or damage the board. Next, we'll work on the output filter inductors, L4 and L5. These two have slightly different values, so it's best to build and install them one at a time instead of mixing them up. Let's start with L4. Take a 12-inch piece of enameled wire and wind 19 turns onto one of the yellow T32-6 toroids. Keep the winding tight and consistent. Once done, scrape off the enamel from the ends and tin the leads. Now insert this inductor into the L4 position. This one is located away from the board's edge. Solder it in place and make sure it sits nicely without stress on the leads. Now for L5, take another 12-inch wire and wind 17 turns onto the remaining yellow T36 toroid. Again, scrape the enamel, tin the leads, and then install it into the L5 position. This is the footprint closer to the edge of the board. Solder it carefully, ensuring good contact and a stable fit, and that's it, your power amplifier stage is complete. Alright, moving on, the kit also includes a few extra components like Berg pin headers, spaces, a microphone element, and a push button switch for PTT. So let's quickly assemble those as well. First up, the Berg pin headers. I'm going to go ahead and solder them directly into the header pin holes on the PCB. This step is totally optional. Next, grab the spacers and nuts. We'll mount them onto the four corners of the PCB. This helps in giving the board some elevation and makes it easier to mount inside a case later on. Now for the interesting part, I've built a small PTT microphone unit using the provided microphone element and the push button switch. For better flexibility, I decided to use a separate small enclosure along with an additional audio socket. This way, I can connect it using a flexible aux cable instead of fixed wires, which makes it much more convenient to use. Let me give you a quick peek inside the PTT mic case. As you can see, it's compact, simple, and does exactly what it's supposed to do. The wiring is pretty straightforward. The ring connection is for PTT, the tip is for the microphone, and the sleeve is ground. Overall, it's a small and handy unit that serves the purpose really well. With this, you've completed the full assembly of the LARCSet transceiver. We'll set the PA bias, check the RF power output, and do the final calibration of the radio. The LARCSet is connected to the Texas port of the power meter. And the ANT port is connected to a dummy load. I've also connected a current measuring setup to monitor live current consumption. The radio is powered using a 12-volt, 2-amp power adapter. Before switching on the radio, rotate the PA-BIAS trim pot fully clockwise. Now connect the microphone to the middle audio jack. Tip is mic, ring is PTT, and sleeve is ground. Press the PTT switch without speaking. The current draw should be around 170 mA. Now slowly rotate the PA-BIAS trim pot anti-clockwise until the standing current reaches around 350 mA. Next, speak clearly into the microphone. The current should peak around 0.6 amps, and on the 5-watt range of the power meter, you should see approximately 3.5 watts output.
Hello. 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 Hello.
Now release the PTT and disconnect the microphone. Next, connect a MOS key to the rightmost jack. On key down, the current draw should be between 0.8 and 1 amp. Switch the meter to the 20-watt range. You should now see around 5 watts of RF output. You can further fine-tune the output by adjusting the BPF coils. After successfully completing the power amplifier bias setting of the PA, it's now time for the next important step, calibrating the dial. Now, the LARCSet is a fully analog radio. That means there's no digital frequency display here. But honestly, that's part of its charm. And because it's analog, one of the simplest and most practical ways to calibrate it is by manually marking the frequencies on the dial using a simple Sharpie marker. This is our favorite method because it's quick, reliable, and requires very little equipment. For this process, you'll need access to another radio transceiver that can transmit CW signals on the 7 MHz band. In this setup, I'll be using a USDX transceiver operating in CW mode. On the LARCSet, I've connected a small wire loop antenna assembled on a BNC male connector. This tiny loop is enough for receiving the nearby calibration signal. Meanwhile, on the USDX transceiver, a dummy load is connected to the antenna port using a jumper cable. This prevents any unnecessary RF transmission while we calibrate. I am also using an external speaker for easier audio monitoring. And one more important thing, the LARCSet is powered using a 12-volt lithium-ion battery instead of an SMPS power supply. This helps reduce switching noise and makes tuning much cleaner. Now let's begin the calibration. First, tune the transmitter radio, in this case the USDX, exactly to 7.000 MHz. Set the mode to CW. Now press and hold the CW key or transmit key on the USDX. On the LARCSet, slowly tune across the band until you hear the CW tone clearly. Once the signal is tuned in properly, mark the position of the tuning pointer on the front panel and label it as 0. I'll fix this in place so you can clearly see the marking process. I'm using this big measuring cup to keep the board upright, allowing the camera to capture all the steps. Now let's begin the calibration. First, tune the transmitter radio, in this case the USDX, exactly to 7.000 MHz. Set the mode to CW. Now press and hold the CW key or transmit key on the USDX. On the LARCSet, slowly tune across the band until you hear the CW tone clearly. Once the signal is tuned in properly, mark the position of the tuning pointer on the front panel and label it as 0. That mark now represents 7.000 MHz. Next, move the transmitter frequency up by 10 kHz to 7.010 MHz. Again, press the CW key on the USDX and tune the signal on the LARCSet. When the signal peaks, make another mark on the dial and label it as 10. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Over time, you'll build a complete frequency scale on the LARCSet's front panel. Of course, there are many different ways to calibrate the LARCSet dial. But the most important thing is making sure your operating frequency always stays within the amateur radio bands. And with that, your analog dial is now ready for real on-air operation. And with that, the calibration is complete. Thanks for following this entire series.